is question number 22, where we have a series of real numbers summation xk, k from 1 to infinity, and summation yl, where y1 is x1, y2 is x2 by 2, and we have a very long definition of yn in terms of x2, x3, up to xn. And there are four statements given about the convergence of yk and x, summation yk and summation xk. Okay. So question number 22, I have written down the values of the yls in the first line, and summation yk, k from 1 to n, is essentially y1 plus y2 plus dot dot yn. And observe that in these terms, x1 comes only once, because x1 is not involved in any other term other than y1. So this is x1 plus x2. x2 appears in all of the terms from 2 to n in the form, and since it's in yn, it is, its coefficient is 1 by n into n minus 1. So it's x2 summation k from 2 to n, 1 by k into k minus 1. And for x3, the coefficient is 2 by n into n minus 1, and it runs from 3 to n. So it's 2x3 summation k from 3 to n, 1 by k into k minus 1. And this goes on, and xn appears in only one term of the summation yk, which is yn, and xn by n, I can basically write it down as xn into n minus 1 by n into n minus 1. So I have just done some simplifications of I've written down 1 into k, 1 by k into k minus 1 into 1 by k minus 1 minus 1 by k. And I have added it, and it's obviously a telescopic series, so all the terms get cancelled. Like for k is equal to 2, the first term is 1 minus half, the second term is half minus 1/3, and so on. So all the terms except the first and the last term gets cancelled. So it's x1 plus x2 into 1 minus 1 by n plus twice x3 into half minus 1 by n, and so on, into n minus 1 xn into 1 by n minus 1 minus 1 by n. So summation yk comes out to be x1 plus x2 into 1 minus 1 by n plus x3 into 1 minus 2 by n plus dot 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 xn into 1 minus n minus 1 by n. So this can be written down as summation xk into 1 minus k minus 1 by n. And now we can observe that mod yk is less than equal to mod xk, because 1 minus k minus 1 by n lies between 0 and 1. And we can mark this down as 2. From 2, if summation xk converges, summation yk converges by Abel's test. In Abel's test, we know that if a sequence summation yn can be written down in the form of summation xn into cn, where cn is bounded and xn is convergent, then summation yn converges. So if summation xk converges, summation yk converges. And further, if we take limit on this statement 1, we can observe that summation xk comes out to summation yk, because the initial terms, this k minus 1 by n part just vanishes when you take the limit, and the final terms where k is actually close to n, the xk values are itself 0, because we know that if a series converges, the tail part of the series has the individual values equal to 0. So summation yk comes out to be summation xk basically. And let me get back to the options. Options B and C, which talk about the convergence of summation yk if summation xk doesn't converge, or summation xk if summation yk doesn't converge. You can observe using the very well-known comparison test, that if a series is smaller than a convergent series, it converges, and if it's smaller than a divergent series, it may or may not converge. You can use that result definitely to check options B and C. And option A talks about that if summation yk converges, then summation xk converges to the same limit. Now this may not be necessarily true, because summation mod yk is less than summation mod xk. So the yk terms are essentially smaller than the xk terms. So if xk converges, doesn't necessarily mean yk converges. Sorry, yk converges doesn't necessarily mean XA converges. So A can be checked using option B. So B and D are the correct options. And obviously, if B is true, A cannot be true.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI Mstat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Yeah. So P is the set of all real polynomials. We are given basically 4 transformations on P, and we have to check which of them give a linear transformation. Now, we take 2 polynomials in the set P, Px and Qx, and 2 real scalars A and B. And we all know that for any vectors, say x curl and y curl, to check that whether transformation is linear, we need to check whether Tx curl plus Ax curl plus By curl is equal to Atx curl plus Bty curl. We'll be using the similar logic here. And if we can find some A or B belongs to the real line, for which this is not true, then the transformation is not a linear transformation. Okay. So we check the first option, which says T of Px is equal to P of x square. So T of Apx plus Bqx, which we can write down as say T of Rx, is R of x square according to the first transformation. So R of x square, since Rx is this, R of x square is just A of Px square plus B of Qx square, which is equal to A of Tpx plus B of Tqx, since T of Px is just Px square. So option A gives us a linear transformation. Now let us go to option B. So option B says Tpx is equal to Px whole square. So T of Apx plus B of Qx is equal to A into Px plus B into Qx whole square. By the similar logic, it can be considered as some T R2x, and this is just R2x whole square. Now this is not equal to A into Px whole square plus B into Qx whole square, which is ATPX plus BTQX. So this thing is not equal to ATPX plus BTQX. So this is not a linear transformation. Checking option C, T of Apx plus PQX is equal to x square A into Px plus B into Qx, because this says that T of Px is x square Px. So taking the two terms separately, this is A into x square Px plus B into x square Qx. So it's A into Tpx plus B into Tqx. So this is again a linear transformation. And checking option D, we have T into Apx plus B into Qx, which is Apx plus Bqx plus x square, which is not equal to ATPX plus BTQX, since TPQX is just Px plus x square and Tqx is Qx plus x square. So obviously these two terms are not equal. So A and C are linear transformations and B and D are not.